Having discussed the Enterobacteriaceae family, let us now begin with the Vibrio and the non-fermenters. So Vibrio, of course, will include all the Vibrio, cholera, parahemolyticus, alginolyticus, vulnificus. Non-fermenters will include Pseudomonas, Burkholderia. These are two main ones that we have to study. So let's get going. When I talk about Vibrio, there is of course a classification. I know all of you are very famously and knowing only Vibrio, cholera, but I'm going to erase that memory of yours for a time being and tell you that this is not the only Vibrio that you have in the world. There's a division that happens known as halophilic Vibrio and non-halophilic Vibrio. When we talk about halophilic, these are the ones which are going to be needing salt. How much of salt? 7 to 10% salt. And non-halophilic are the ones that cannot grow in high salt. So non-halophilic, non-salt loving. They don't need salt. And your Vibrio, cholera and mimicus come under this. Vibrio, cholera and mimicus is the one that is going to mimic the cholera. So Vibrio, cholera and mimicus are for this. And all the others that you know, that is parahemolyticus, alginolyticus, vulnificus, all of them are going to go into the halophilic variety. So obviously first I'm going to start off with this Vibrio cholera story, which is everyone's favorite, and there is a famous classification that we have. Please note that everything for Vibrio is going to start off with something known as Venkat Raman Ramakrishnan. Everything about Vibrio has been given by this scientist. So please note there is a Gardner and Venkat Raman classification that we have. Everything. So when I'll tell you about some culture media also, they will have the same name, that is the Venkat Raman. So remember, the Venkat Raman and Gardner classification says that Vibrio can be divided into Vibrio, cholera as well as the others. And on the basis of that, on the basis of the O antigen, we have divided it into, what did I say? There is O1, then there is O139, and then everything in between has been clubbed under one group. But I am primarily interested in O1, and O1 has further subtypes. What are the biotypes that you have? Classical, LTOR and LTOR variants. Again, my concern is going to be between classical and LTOR because each one of them is divided into 3 serotypes, and those are known as Ogawa, Inaba, Hikojima. Like a story or a rhyme, like a student rhyme, you will have to learn Ogawa, Inaba, Hikojima. So classical is divided into Ogawa, Inaba, Hikojima. LTOR is divided into Ogawa, Inaba and Hikojima. That is how it's going to happen. So repeating all of this once again, please note, first we had what? We had the famous division into O1, 139 and everything in between. These are then divided into classical, LTOR and LTOR variants. Classical and LTOR are each divided into Ogawa, Inaba and Hikojima. Sorted? Let's move forward. Now my concern is you will get questions on how to differentiate between classical and LTOR. How am I going to learn it? Please note, whatever tests I will tell you, LTOR will be positive in it. LTOR is positive in all the tests. LTOR is the one that is going to be resistant for a lot of cases, and because of that, it is going to have the carrier state. So remember, positivity, resistance and carrier means if I say which of them is going to be showing you beta hemolysis on sheep blood agar, you will say LTOR will be positive. Which of them is going to show you chick erythrocyte agglutination? Of course, LTOR will be positive. Which of them can show you the Voges Proscure test positive? That is going to be LTOR. So like I said, LTOR will be positive for a lot of things. One more part of the table, if I ask you which of them might sometimes show you CAMP test, again it is going to be LTOR. So like I said, any testing that is asked, LTOR is going to be positive out of these. Any sensitivity asked, LTOR is going to be resistant. So please note, polymyxin B sensitivity, LTOR is resistant. Phage 4 susceptibility, LTOR is resistant. So anything asked, LTOR is resistant. Anything asked, LTOR is positive. And what about the carrier state? Who is going to have more chances of carrier state? So that is going to be LTOR. This means the original disease and mortality and secondary attack rate is less. Means all of that is going to be less. If it's going into carrier state, this means it's going beyond the mortality. It's going beyond the secondary attack rate, right? So all these situations are less and the carrier state is more. So one of the easier way of learning all this table was any testing that will be asked, LTOR will be positive, whether beta hemolysis or chick erythrocyte agglutination or VP test or CAMP test, sub LTOR positive. Any sensitivity that will be asked, so LTOR is going to be resistant and it's going to result in a carrier state. So now I want to take you guys into a little bit of epidemiology because at a time when you were not even born, 1992, that is Chennai mein, there was a non-O1, not O1, the other O30, 139 and others ka outbreak hua tha, and O139 ka strain outbreak in 93 in Bengal was also quite famous. So maybe many years later, like your kids will also know that there was something that happened in 2021, 2 and 3, where there was something known as COVID that came in. Yeah, so this is, I'm talking about a time when you were not born probably. Now in India, so I can see most of them were classical strains, but now they are saying in India the L-Tor variant has come up, except in Rishikesh where you still get to see a lot of classical variants only. But in India overall the L-Tor strain is coming up. So what is the pathogenesis? Before I start, I hope everyone is aware that when I'm talking about Vibrio cholera, or I'm just talking about cholera in general, you know that there is something to do with rice water stools that has been affiliated, right? There is rice water stools that you all have to know. So how is rice water? Rice water means a lot of watery stools, a lot of electrolytes and water wala stool is going to be there. So firstly, the transmission of course is contaminated food and water, so fecal-oral. The infectivity dose is very high. Imagine we need how much of bacteria? 10 to the power 8 colony forming units. This is quite a high infectivity dose. Why is that needed? Because most of the Vibrio are going to get killed by the acidic environment in the stomach. By the acid in the stomach, most of the Vibrio are going to be killed. So for the Vibrio to be able to cause infection in me, it should have a considerable amount of infectivity dose. Then, now I'm going to tell you some basic points before I get into the main story. If I say this is the intestine, and mostly I'm talking about the villi wala small intestine, every intestine has a mucus layer, right? So first you will say, how is the mucus layer damaged? The mucus layer is going to be crossed by mucinase, of course. So this is getting number one virulence factor, it is getting mucinase. Mucinase is going to come. So I'll write mucinase over here. Mucinase is going to come and is going to break off all of this. So mucin is broken by mucinase. After that, it has to adhere onto these cells. How is it going to adhere onto these cells? By a regulated pilus. See, attachment ke liye have I told you in your general micro, for attachment there is pilus. So remember, for attachment there is going to be toxin co-regulated pilus. For attachment it has a pilus, toxin co-regulated pilus. And after that, how is it going to disrupt the cells? The disruption of the cells and their tight junctions. Tight junction ka example, zona occludens. So there is a zona occludens toxin also. So let's do a recap. Number one, if it has to cross the mucus, it has something called mucinase. Second, if it has to adhere, it has a pilus, toxin co-regulated pilus. And if it has to break the tight junction, it has a toxin for that, and that is the zona occludens toxin. So now I can take you guys into actually the toxin, the main toxin jiska naam hai. These were all chota toxin. The main toxin is CTX. CTX stands for cholera toxin. And like all other toxins, it is bipartite, means it's going to have a fragment A and it's going to have a fragment B, out of which they say the A wala is responsible for the mechanism of action and the B one is responsible for binding. So what mechanism of action? It is going to activate the adenylate cyclase. It is going to activate the adenylate cyclase. Basically, there is an increase in cyclic AMP that is noted, whereas the binding is going to occur to the GM1 ganglioside. I'll show you a graph also for this, a chart also for this. So remember, the binding happens to the GM1 ganglioside and the action is going to be an increase in the cyclic AMP. So what happens? Pehle to I'll show you a diagram. See what has happened. This is the cholera toxin. Is it looking just like A and B? No. I can see that A also has two parts called A1 and A2 and B has 5 subunits to it. I can see 5 Bs written. That is what we say. Although many students believe it is bipartite, actually it is going to contain 2 subunits of A1 and it is going to contain 5 subunits of B. So that is what it has. So B is at the periphery. It's going to help in binding, and A1, A2 is going to do the action. So tell me, what does A1, A2 do? It is going to increase the adenylate cyclase activity. It is going to increase the cyclic AMP. But for binding, which is the ganglioside to which it came and bound to, for binding it had used GM1 ganglioside. So first it bound to GM1 ganglioside. Now the cyclic AMP has been activated. What beyond? I can see one receptor getting activated, the cystic fibrosis transmembrane protein. So please note, there is a phosphorylation of the CFTR, cystic fibrosis transmembrane regulatory protein. And once going back, you will find this in the diagram. Yes, ma'am, look at this. B se kya hua? Binding hua to GM1 ganglioside and cyclic AMP then by A toxin got activated. When cyclic AMP got activated, I can see that the CFTR gene is getting affected, and because of that I'm seeing all the chloride and the water is going out into the lumen. Chloride and water, rice water stools are forming. There is basically ions getting secreted in the lumen, and this is responsible for the rice water stools. So now what are the questions that you will get? Question number 1, I'm marking the questions, watch out for it. Question number 1 is going to be which toxin? Cholera toxin. Do you know the structure? Yes, A1, A2, BB, BB. Okay. After this, what is B going to bind to? It is going to bind to the GM1 ganglioside. What is A going to do? It is going to increase the cyclic AMP. That is going to have an impact on which receptor? The cystic fibrosis CFTR, and then that is going to result in rice water stools. Now, before I move ahead, can you give me a list of all the toxins till now that you have studied which increase cyclic AMP? Kya mnemonic hai? Cyclic AMP. You write cyclic AMP and you just kind of twist this M, it will start looking like E. So your mnemonic becomes CAEP, means number 1, what you're reading right now, cholera. Next, I've already taught you Bacillus anthracis also increases, edema factor, remember? It increases cyclic AMP. Then enterotoxigenic E. coli. You'll say, ma'am, which toxin of E. coli? The labile toxin or the stable toxin? I told you labile in the air. Labile in the air. So that is going to be cyclic AMP. And also another thing which I'll be teaching you in the next chapter, and that is going to be Bordetella pertussis. So remember, the cholera toxin, the anthrax toxin, the E. coli wala toxin, labile wala, and going to be the pertussis. All of these include the cyclic, increase the cyclic AMP. So now the cyclic AMP has been increased, and now there is going to be a rice water stool that will occur. So what is the incubation period? It is somewhere between 1 to 5 days. And of course, we are going to be the reservoirs. But who's the carrier? Tell me just one thing. Carrier state, if you had to select between the LTOR and the classical variant, carrier state is going to be more for what? We have already studied LTOR is going to have more of carrier state, and these are going to be rice water stools. What is rice water stools? Have you ever entered into the kitchen in your house and seen that before cooking rice, you soak the rice in water, and once you soak the rice in water, the water becomes a little whitish and a little turbid. So that is what is rice water stools. It is a mucus, flaky, turbid water, which has, you must have seen if you keep rice soaked in water for a very long time, that it tends to become very, very foul smelling if you prolong that soakage. Fishy odor, and since this is diarrhea, it's going to be a sudden onset. So sudden onset of a fishy odor, fishy, flaky, and fatafat. Okay, so if you see something like a fishy odor which is going to have a flaky, and it's going to happen very fatafat, that is what you call as the rice water stool. So how are you going to do the diagnosis? In the sample, either you're obviously going to get the stool sample, just in case patient comes to you at a time when the stool is not available, you're going to take up the rectal swabs. That makes sense, right? So either of the two rectum related samples you will get. Now the stool, of course, is going to be the very, very famous rice water stools. You'll see it, you'll know it is fatafat, flaky and fishy. But what is the transport media? Now I told you everything in Vibrio had to do with Venkatraman scientist. So one of the transport media is Venkatraman Ramakrishnan medium, and one of the transport media is the Carey-Blair media. So Carey is for transport, Carey-Blair medium. So remember, Venkatraman Ramakrishnan and Carey-Blair, these are the two scientists on which the transport media have been kept. Now, once you've got the sample in your lab, you're first going to look at it under the microscope. Then you're going to do some tests. Then you will put it in some culture. So when you first look at it under the microscope, what do you see? We see the famous comma-shaped organism. Comma shape or curved organism is what you are going to identify, and the color is not looking purple. Why? Because this is a gram-negative bacillus. You can very well see the comma shape, that you can easily appreciate, and they are little reddish because they are gram-negative. But if you look carefully, there's a line coming out through them. Why? This is a flagella. Of course, they are motile. What is the motility? There is a very famous motility that you see in them, that is known as the darting motility. This is known as the darting motility. Some people also call it the shooting star motility. So like a shooting star, like a broken star, it just goes in front of you within seconds. So shooting star or darting motility, and you can make a chota sa table over here which tells you that shooting star or darting motility is not just shown by Vibrio, it is also shown by Campylobacter. It is also shown by Campylobacter, which I will be teaching you in the last part of bacteriology, that is miscellaneous. So shooting star or darting motility by Vibrio or Campylobacter, they are going to be comma-shaped organism. And if you see, if I draw it, comma-shaped organism, and flagella is coming out from one pole like this. So can I say they are monotrichous? They are going to be monotrichous. So imagine there's one like this, then again there is another like this, then there is another like this. Can I say this has resulted in another appearance known as the fish in stream appearance? In some time, I will be talking about school of fish appearance. Very common confusion. Ma'am, what is school of fish appearance? What is fish in stream appearance? This is fish because I told you Vibrio cholera is fishy odor, flaky diarrhea, fatafat diarrhea and fish in stream appearance. So fish, as if you know the fish are swimming and these are their tails. The fish are swimming. So fish in stream appearance is going to be seen with Vibrio. So comma-shaped curved organism with very quick shooting star darting motility. Fish in stream appearance, the same can be seen as darting motility in Campylobacter also. Now let's come to the culture. I think I have already told you that this definitely belongs to a non-lactose fermenting condition. Can you grow it on a blood agar and a nutrient agar? Yes, you start getting some different colors to it. So if you grow it on a blood agar, you get a green color, and if you grow it on a nutrient agar, you again get a bluish. So I have learned दोनों में कुछ bluish tinge आता है. This is very miscellaneous information which will not be your picking up point in the exam is not this. No one's going to expect you get that blood agar is going you a greenish hemolysis or you know your nutrient agar is showing you a bluish tinge. So इस पे diagnosis बनाओ. No, diagnosis will come first on rice water stool. But the gelatin swabs can definitely be given to me. This shows you a napiform or a turnip liquefaction. Now how I have learnt it, please learn. You cannot have rice alone. You can't consume rice, just rice. So when you had rice and water, you said, I want a vegetable. I give you a vegetable that is turnip. So jahan pe rice water stool hoga, over there you will have turnip liquefaction of gelatin, turnip or napiform liquefaction of gelatin that will happen. What are the gelatin stabs that you have learnt up till now? If you remember, for Bacillus anthrax you had learnt. Then for Clostridium tetani, one was fir tree, one was inverted fir tree. So I had learnt Clostridium tetani was fir tree, seedha tree. Fir tree appearance was there, whereas Bacillus anthracis was inverted fir tree. Bacillus anthracis was inverted fir tree. Now I'm telling you that the gelatin appearance for Vibrio, because you have rice over here and you need a vegetable along with it, so you've decided to keep turnip along with it. Now these are all your miscellaneous culture media. The real will start. What is the enrichment broth and what is the selective media? So what all have you studied up till now? Real pado. First they will be asking you the transport media. Then they will be asking you the gelatin wala property. Then they will ask you the enrichment media, and then they will ask you the selective media. These are the ones that you have to know. Transport mein two scientists were there, Venkatraman Ramakrishnan and Carrie Blair medium, done. In gelatin, I've told you, you had to think of that turnip or that napiform gelatin liquefaction. That also you have done. Now let's come to enrichment. Something alkaline will be there. Either you can have some APW, that is alkaline peptone water, or you can have another peptone water that is MTTP. MTTP is what? Monsource taurocolate tellurite peptone water. So some peptone water you have to consider, either alkaline peptone water or some tellurium taurocolate kind of peptone water has to be there. That is of water because enrichment broths, enrichment media are always liquid, so some water will come here. Okay, now we come to the selective media. You have a lot of selective media. I'm telling their name, but the main one is going to be TCBS. What are their names? Pehle to jaldi se go through their names once. ABCA, again everything has to be alkaline because I told you na acid mein to they are going to die. Like stomach ke acid mein they died. Alkaline is what you need for their survival. Alkaline bile salt agar, number one. Then gelatin, taurocolate, trypticase, tellurite agar. Wherever the word tellurite will come, you will always get a black color. Recall with me, where have you studied something called potassium tellurite agar? Come on guys, there also I told you that when you will see a tellurium, you will see a black color. So potassium tellurite, black color, Corynebacterium diphtheria. I hope all of you could revise it. Nahi bhi yaad aaya, the rule of microbiology is never get depressed. A person who learns microbiology, he is made of steel, is made of rock solid material. Means that person is never going to be affected. Bhool gaye, laugh over it. Because you're supposed to forget it. Micro is something you will always forget. Read, forget. Until the last minute before your exam, that life cycle of, this is your microbiology life cycle. Read, forget. And this will keep going on. There is nothing known as knowing 100% microbiology. No one has ever been able to remember it. Even the topper has major confusions. You need to know the main things. So abhi you are reading through the entire entire syllabus. My advice is that later on you go through the RR, because that is definitely going to give you a great extra edge, and that will assimilate a lot of things for you. So wherever tellurite word comes, a blackish color is going to come, and that is going to be for Corynebacterium diphtheria. So we have the gelatin tellurite agar, which is giving a black color, some alkaline media, but this is the main one. TCBS, thiosulfate citrate bile salt sucrose. This is what I would want to revise. So what did I say? TCBS. There is thiosulfate citrate bile salt sucrose. First and foremost, that you know sucrose likha hai, to ma'am, this is finally the place where you're gonna tell me the sucrose fermentation. Yes, this helps in differentiating sucrose fermentation versus non-sucrose fermentation, because Vibrio cholera is a sucrose fermenter, whereas the other members of the family, for example Vibrio parahemolyticus, they are non-sucrose fermenters. Number one. Number two, where I told you whenever anything will get fermented, what is the color that you're gonna get? For sucrose fermentation, we get a yellow color. For any fermentation, I've been telling you a yellow color, except for that pretty pink McConkey. That pretty pink McConkey was pink color lactose fermentation. Rest everything else was the yellow color fermentation. So here sucrose is also yellow, but if a color is coming, there must have been an indicator. This is where students have a problem. They feel, अरे कुछ green लग रहा है, कुछ green indicator होगा. No, the indicator over here is bromothymol blue. The indicator that is used over here is going to be bromothymol blue. That is a little bit of catch that you have. Okay? So now going forward, we have the very famous Vibrio cholera, which is a sucrose fermenter, and that you can write. So Vibrio cholera is a sucrose fermenter. Vibrio parahemolyticus is going to be a non-sucrose fermenter. So all your selective media are done. Now comes the chemical reactions, and you want to run away, I know. But I've made a very interesting mnemonic. See, you have been demanding so many things. First, you are demanding rice and water for me, that ma'am, I want to eat rice and water. Then you say that I want a vegetable also along with it. I gave you turnip also. Nothing is gonna come for free. So where are the coins? Give me money. Then only I will provide you all of this. So remember, if you're asking me for such a nice meal of rice and water and turnip, vegetable, you have to give me some coins. Quickly revise with me what are coins. So Vibrio cholera shows you cholera red reaction. It shows you C for catalase positivity. So cholera red reaction, catalase positivity, oxidase positivity, I, N together for indole test, N alone for nitrate reduction, S for sucrose lysis, and S for string test. So repeating once again, catalase, cholera red reaction, oxidase, indole, nitrate reduction, sucrose lysis, string test. एक बार और, the cholera red reaction, catalase, oxidase, indole, nitrate reduction, sucrose lysis, string test. What are the details out of this that you have to know? The first one, cholera red reaction. There are two kinds of students whom we have. The number one students who love to just learn the main important word and move on, and seconds are the curious ones who want to know every little reaction. So for the curious kids, I have taught you that cholera red reaction is one of the easiest thing to do, because you know it is for cholera and it is going to give you a red color. So they ask you, why does the red color come? The red color is a nitroso-indole compound. Please note, this is your previous year question. The red color is a nitroso-indole compound. Bana kaise? I'll quickly tell you. You take Vibrio, and you know you've taken it in that enrichment medium, that is alkaline peptone water, right? You know what alkaline peptone water has? It has tryptophan and nitrate. So what does Vibrio do? Right now only you have told me that Vibrio is going to show nitrate reduction. So nitrate to nitrite hoga. Remember that Coins mnemonic mein you told me it shows nitrate reduction. Then you are also telling me that it tends to show you indole test positive. So theek hai, so it is also going to, from tryptophan it is going to form indole, from nitrate it is going to form nitrite. So nitrite, so basically what has occurred? You have formed a nitroso-indole reaction. You add sulfuric acid, you will get a red color. That is what is cholera red reaction. So simple, the question will be, cholera red reaction is because of which compound? It is because of a nitroso-indole compound that you have over here. That is cholera red reaction. Last one, what is string test? You've seen the picture a while ago. A while ago, you must be noticing that what is this picture that ma'am did not explain? This is the final collage of Vibrio that I had shown you. Comma shape appearance you have seen. TCBS, sucrose fermentation, yellow color dekh liya. Finally, you see something is becoming like a string over here. You know what you did? You took the rice water stools, and to that you added 0.5% deoxycholate. You added 0.5% deoxycholate and suddenly you saw that there was a stringiness that appeared. How? This was water. Can you ever pick up water like this? Nahi na? Then how is it become so stringy? Because please remember, when you treat it with 0.5% deoxycholate, kya hai? It is a toxic bile salt. The organism is gonna damage out. The organism will damage and the DNA will come out. And you know that DNA gives that stringiness. So basically the Vibrio will damage out. It will get damaged. The DNA will come out and those stringy that you're getting is actually the DNA and that is known as the string test. So that gives me something. Where all in microbiology have you studied the string test? You're gonna tell me 2 string tests of microbiome lab and 1 string test in the patient. So 1 string test that is in front of you is gonna be the string test that we have for Vibrio cholera. The second string test that you have studied is just before this in the Enterobacteriaceae family, which was also shown by Klebsiella, because Klebsiella has mucoid colonies. So stretchy hota hai, stringy hota hai. These are the 2 that you see in culture plates. What is the string test that you see in parasitology that you do for the patient? Giardia lamblia. Whenever you have to take out a sample from the duodenum, you put a string inside. So you put a string inside the patient and get the sample from the duodenum. So that is a patient wala string test. These 2 string tests that we have for Vibrio and Klebsiella are microbiology lab string tests. So repeating, if you want rice water and turnip and so many demand, you will have to give me coins. Catalase, cholera red, oxidase, indole, nitrate reduction, sucrose lysis and string test. Finally, all these were tests for Vibrio, but I am pretty much interested in the tests for the toxins, cholera toxin and different toxins that I taught you. So these are all animal based tests, out of which the adrenal tumor Y1 cell assay is very famous. I know you can't learn every animal and everything because it's tough, but the Y1 adrenal tumor cell assay is important. And if kuch bhi nahi yaad aayega exam mein, to mark ELISA. ELISA is definitely used for every toxin. What do you give in the treatment? Most of the cases, it's a supportive treatment and you just have to give ORS, fluids. Antibacterial antibiotics are given only if needed. So what is the drug that you give in adults? You give doxycycline. But what if you are dealing with some pregnant female and children? Azithromycin. But in most of the cases, antibacterial is not needed. It's an ORS and a supportive treatment that works. Now tell me, what is the vaccine? So on the basis of that, we now give a live oral vaccine that is available. That is the vaccine. There was a killed preparation also, but we prefer a live oral vaccine. So this was Vibrio cholera, non-halophilic, no loving for salt, which was the other one which had no love for salt. Mimicking the cholera. Mimicking the cholera was mimicus. But remember, mimicus is because of some machi related, seafood related food. So please remember, mimicus is gonna be something related to machi, or in other words, it is related to seafood. So I had told you one machi last time also in the previous chapter. There was another thing that is known as Morganella. Morganella was belonging to the Proteus family. Morganella was also because of fish consumption, machi consumption. Now I'm telling you mimicus. Mimicus or Vibrio mimicus, that is also because of seafood or fish consumption. So this is done, all the non-halophilic are done, but I am interested in the ones that love salt. That is halophilic organisms. The one that loves salt, that is the halophilic organisms, belong to Vibrio parahemolyticus, vulnificus and alginolyticus. So we'll correct that. That is Vibrio parahemolyticus, Vibrio vulnificus, and we have the alginolyticus. Ab sabse pehle, you will say, ma'am, all of them are salt loving. 7 to 10% salt, all of them will survive it. But which is the most tolerant to salt? NaCl 10% and above. Alginolyticus, this question has come very often in the exam. How do I learn it? Guys, are you fond of those MasterChef and cookery shows that come and how they show you every ingredient? Have you ever seen Chinese food preparation in MasterChef? And you must have seen that in Chinese food, especially India, the Chinese food that is made is very spicy, very salty, high on salt. You know what they add in Chinese food? They add a product called Ajinomoto. I made this mnemonic because I was studying side by side and watching MasterChef one day. So then they were teaching Ajinomoto is put in Chinese food to make it salty and spicy. And then I said, oh, Ajinomoto is sounding like Alginolyticus. So Alginolyticus is Ajinomoto. Chinese food very salty. Alginolyticus grows in maximum salt. That is how I learn it. Okay, so we have 3 things. We have parahemolyticus, vulnificus and alginolyticus. All 3 of them have something in common, that they are capable of causing wound infections. All 3 of them, the halophilic one means जले पे नमक छिड़कना. Okay, जले पे नमक छिड़कना. You've heard that muhavra, na? So namak means halophilic salt, and this is some wound. So on some wound you are sprinkling salt. So wound infection will happen with all these salt-loving organisms. What else? Please remember, parahemolyticus is associated with gastroenteritis, and that too specially associated with seafood wala gastroenteritis. Vulnificus is also associated in, if you have, see, two kind of people you have. Either you have a normal person, matlab immunity bilkul theek. In that, with vulnificus also you will have gastroenteritis. However, if you have a person who's either HIV positive or a person who's undergone some liver cirrhosis, then in that person you will have something very severe. You will have sepsis. So repeating once again, in a normal person you will, normal matlab immunocompetent, okay with immunity person, that is gastroenteritis. Whereas in HIV or cirrhosis, you're going to have sepsis. Versus what is alginolyticus? Ajinomoto wala, which is the one which is most commonly going to have love for salt. So there's going to be eye and ear involvement. So I've drawn the eye and ear. There is going to be conjunctivitis, and there is going to be otitis media. Conjunctivitis and otitis media. So repeating, all the halophilic ones, parahemolyticus, vulnificus, alginolyticus, out of which alginolyticus is the most tolerant to NaCl. Ajinomoto. All of them are jale pe namak, that is they're going to cause wound infections. Parahemolyticus causes food poisoning. Vulnificus also causes food poisoning, but vulnificus can, if the person is vulnerable. If the person is vulnerable, like HIV, cirrhosis, तो उससे क्या होगा? Sepsis. Alginolyticus, eyes, conjunctivitis, ears, otitis media. Now, which out of these, I already told you all the Vibrios are non-lactose fermenter. The only Vibrio that can be a lactose fermenter is vulnificus. Little bit ratta you will do, vulnificus can be lactose fermenter. Now coming to parahemolyticus, because this is gonna get me the maximum questions. Parahemolyticus is motile. Parahemolyticus has a flagella, it is motile or it is mobile, and it shows you something called Kanagawa phenomena. What is Kanagawa phenomena? That I'll have to take up separately. Kanagawa phenomena, if you want to see that, it has a simple phenomena. It says you will have to use a Vagat-Suma agar. What is Vagat-Suma agar? Vagat-Suma agar is a blood agar which has approximately 2 to 4% salt in it. It is a blood agar with 2 to 4% salt in it, and that says that if you will have a pathogenic strain, that will show you hemolysis. If you will have a non-pathogenic strain, that will not show you hemolysis. How simple. Basically, you've used a blood agar, na? So on a blood agar, all that you can see is hemolysis or non-hemolysis. So if you see hemolysis, means it is a pathogenic strain hai, to hemolysis hoga. Pathogenic strain nahi hai, to hemolysis nahi hoga. That is known as the Kanagawa phenomena. So remember, Vibrio parahemolyticus shows you the motility, shows you the Kanagawa phenomena. One last thing before I end this Vibrio, can you help me guys with this small information, and that is which of them can show you swarming? Because I told you mnemonic for swarming in the previous chapter called PVCs, in which I told you parahemolyticus and alginolyticus are responsible for showing you swarming. Yaad aaya? Yes, this is what. So I realized that these two periphery wala show me swarming, and this vulnificus is going to show me lactose fermentation. So this is like my final go-to summary, and all the halophilic salt-loving organisms are sorted. I'm not solving any questions as of now. Vibrio is done. I'm taking a one more family. That one more family is going to be non-fermenters. After that, we will come down to the questions. You might get a little scared, but you don't have to read all. Remember, there is something called non-fermenters. So Vibrio, I hope everyone's understood. Can I move on to non-fermenters? Non-fermenters means they will use sugars oxidatively. They will use the sugars oxidatively. They are non-fermenters. That includes pseudomonas, different types of Burkholderia, malai, pseudomalai, Cepacia and all. And if you want to read, there is something called Acinetobacter baumannii. So obviously the most important out of these will be pseudomonas. I'm starting with that, but most of the things about pseudomonas you have read. Firstly, tell me, pseudomonas is gonna be a gram-negative organism, of course, and it is catalase and oxidase positive. Guys, do you remember that mnemonic space being made for the catalase positive organisms, and space mein P was for pseudomonas, right? So this you already know. Virulence factors also you know. You know Pseudomonas is gonna have a capsule. You know Pseudomonas has lot of, every time I used to say Pseudomonas is blue-green, lots of pigments will come. It will have something which will called alginic acid and some toxins, and I know you know the mechanism of the toxins, but let's go one by one. Yes, it has a capsule. It has pigments. What is pigments? Pigments is most common pyocyanin, and it is actually seen with which Pseudomonas? It is seen with Pseudomonas aeruginosa. It is seen with Pseudomonas aeruginosa. So pyocyanin, cyanin tells me that this is a blue-green pigment. It's blue-green in color, and if you want to enhance it, so how will you enhance the pigment? In the King's medium. King ke Raj mein you are going to enhance it. So this is going to be in the King's medium that I will enhance the pyocyanin. Pyoverdin, verdin, like we always used to say biliverdin. So biliverdin kya hota hai? Greenish yellow. So pyoverdin is also greenish yellow. So that you can say in a way is showing you that fluorescent wala color. So if they say who shows you fluorescent greenish yellow color, pyoverdin. Also note pyoverdin is a siderophore. It might want to take up iron. Pyoverdin. So this pyoverdin is going to be the greenish yellow. Pyoverdin takes up iron. Pyorubin, the word is only telling you red color ka pigment hoga. Pyomelanin is telling you kuch brownish, blackish melanin type of pigment hoga. So if I give you this picture, you know for a fact that the entire slide, entire culture plate has become blue-green. So this of course must be a pyocyanin, and that is exactly what I want to ask you. See, the culture is only over here, but the blue-green color has gone everywhere. The blue-green color is everywhere, which tells me that this is definitely a diffusible pigment. This is 100% a diffusible pigment that we have, because now I want all of you to recall. There was something called Staph aureus, there was something called Serratia, and now we are doing something called Pseudomonas. Can you recall their colors? So Staph aureus, AU for golden pigment. Serratia had lot of R's, so I had learned red pigment. Pseudomonas, I don't need any mnemonic because even the world knows it is a blue-green pigment. But the difference is that Pseudomonas is the only one where the pigment is gonna be diffusible, because I can see that the entire plate has become green in color. Whereas when I'm dealing with Staph aureus and Serratia, no, it's nothing like that. They are gonna stay exactly where the colony is. They are all gonna be non-diffusible. Okay? So coming back, you're done with all the pigments and the capsule. Then there is something called alginic acid. Alginic acid basically helps in making a biofilm. So जो भी वो slimy layers होती है ना, the mucoid strains होता है. So all the mucoid strains of Pseudomonas will make a biofilm made up of alginic. Next we have toxins, and I think you already know the toxins. We have exotoxin A, and like any other thing on this planet, it has fragment A for mechanism of action and it has fragment B for binding. But I'm not going to tell you the action because I've told you the action a million times. Remember, there was something called decreasing protein synthesis, which are all the toxins which decrease protein synthesis. So D was for diphtheria toxin, S was for Shiga toxin and Shiga-like toxin. And finally, I had told you so many times for P that it is the exotoxin A of Pseudomonas, and that is what you have. It is the exotoxin A of Pseudomonas. And how does it decrease the protein synthesis? So now I can clearly tell you that how is this exotoxin A going to decrease the protein synthesis? Tell me guys, by acting on elongation factor 2. Yes, it is going to cause the ADP phosphorylation. It is going to cause the ADP phosphorylation of the elongation factor 2, and then it is going to cause decrease in protein synthesis. So this is the main virulence factor. Of course, there are enzymes and enterotoxins. They have proteases, elastases. Those are there. Slime layer, I've already told you, alginic acid can make a biofilm. It can make a slime layer. Pili is there for attachment. These are there in every bacteria. So nothing new. The primary one was definitely number one, the toxins, and number two, all these pigments are very, very important. After doing toxins and pigments, it's time for the clinical features. This is a very famous picture. If they give me anything greenish, bluish in color, the first bacteria coming to my mind is Pseudomonas. So please note that if they say something like there is a green nail syndrome, like you can see this over here, the green nail syndrome, of course it's Pseudomonas. If they say burns may, trust me, Pseudomonas is a very, very important infection. Burns patients may Pseudomonas. So what is the secretion? The color of the secretion will be blue. UTI, especially catheter-associated UTI, the color of the urine might become blue. Meningitis, the color of the CSF might become blue. Then you have contact lens-associated corneal ulcers. Yes, that can also be blue. There can be hot tub folliculitis, which is also related with jacuzzi. So jacuzzi or hot tub ka history hoga. Similarly, on the basis of water, they could have something called swimmer's ears. Swimmer's ears is nothing but simple otitis externa. Simple otitis externa is going to be the swimmer's ear. So either there's some water related history, ya fir har jagah there's going to be a bluish tinge that is going to be there. Apart from that, of course, it can cause hospital and ventilator acquired pneumonia. Pneumonia matlab the sputum is going to become blue-green. And finally, there is Shanghai fever. What is Shanghai fever? Shanghai fever is going to be sepsis along with enteric disease, intestinal involvement also. Sepsis along with enteric disease is going to be Shanghai fever. So fancy words are their favorite. Green nail syndrome pakka पूछेंगे. Shanghai fever they will ask. Hot tub folliculitis they will ask, and swimmer's ear they will ask. These fancy names for Pseudomonas, they will definitely ask you. So I can realize that, Pseudomonas is coming across as a nosocomial infection. It's definitely coming across as a nosocomial infection. So I think this is the right time that I tell you that WHO has given a list of priority organisms, and it has told you which are the nosocomial infections which are very dangerous, very virulent, which are also going to have multi-drug resistance. Basically, they are escaping the rules. WHO has given priority organisms called escape, which are very dangerous. Of course, the P ones you have anyway understood it is Pseudomonas aeruginosa, but others also you have read. Have you already studied the Enterococcus faecium in the first chapter and the Enterobacter species? Enterococcus ke sath you read another coccus, and that was Staphylococcus aureus, so that is also done. Previous chapter Klebsiella pneumoniae done. In this chapter you're going to read Acinetobacter baumannii. So these all are going to be the ones. Repeating, Enterococcus and Enterobacter. Then the Enterococcus tha to agla bhi Staphylococcus. Then in this family you are doing Pseudomonas aeruginosa and Acinetobacter, and K se to of course what's going to come to my mind is Klebsiella only. So these are the escape which are said to be the priority organisms for nosocomial infections. So we are almost over with our story of Pseudomonas, but there is a list over here which I'll read through, and then it's tough to learn, so I'll give you a mnemonic. So microscopy mein, don't I already know that this is going to be a gram-negative bacillus? Of course, yes, that much information I know. Pigment produced is enhanced by which media? The King's media. Please note, it gives a very sweet or a fruity odor in most of the cases. This organism has a sweet or a fruity odor. Second, whenever the colonies are formed, they tend to shine, and that property is known as iridescence. Iridescence means that whenever the colonies will form, they will shine. Are they fermenters? No, the first topic was they are non-fermenters. They use sugars oxidatively. Are they lactose fermenters? Not at all. What will they show on blood agar? Beta hemolysis. What is their selective media? Cetrimite agar. How do I learn all of this information? So now please let me tell you the story of Pseudomonas. So the P will tell you that this is the organism that produces a lot of pigments, and if you have to talk about the pigments and how are they going to be enhanced, they are going to be enhanced on the King's media. Okay. Coming to the next, what is the odor that you have? They tend to have a sweet or a fruity odor. They tend to have a sweet or a fruity odor. Coming to E, right now you were saying that it shows you iridescence. So I'm writing that in a way. It is showing you iridescence. Iridescence means that the colonies are going to show you a metallic shine. The colonies are going to show you a metallic shine. Next we come to how do they use sugars? We already know they use the sugars in an oxidative manner, not in a fermentative manner. Next, remember they are also very importantly, if I show you what I was wanting to tell you earlier was they can be motile. Please remember they can be motile with a polar flagella. Now when I talk about their very famous, the blood agar, talking about their agar, they are going to be beta hemolytic. On a blood agar, they are going to be beta hemolytic. What else? What is their selective media if I ask you? The selective also has an S wala sound. Selective media is a cetrimide agar. The selective media is a cetrimide agar. Life has become a little simple, isn't it? So let's do a quick recap, guys. Although it's kind of understood understood, they are non-lactose fermenters, and I know that, but completing my mnemonic I can do. Also with S, you can learn all the S and N jo bacha na, you can learn all the clinical features. Can't you learn the Shanghai fever and the simple otitis externa? Can you learn the green nail syndrome with it? Can you learn the swimmer's ear with this? So all the clinical features also. Repeating, swimmer's ear. So let me go back to the clinical features. You can very well see that over here when you're talking about S say swimmer's ears, S say you had Shanghai fever, S say you had the different kind of sepsis or Shanghai fever or simple otitis externa that you have, N say you have green nail syndrome. So in a way, the Pseudomonas is serving as a mnemonic which takes everything into account. This is my favorite mnemonic that I have made, that I feel that I have clubbed one chapter into one. It's a big achievement that I feel. Okay, so pigment hai, then sweet fruity odor, iridescent, uses sugars oxidatively, it is motile, it is non-lactose fermenter, on agar it is beta hemolytic, on cetrimide selective agar. How are you going to do finally the susceptibility? Of course, I have told you a million times that you need to do antibiotic sensitivity testing, but did I tell you that Pseudomonas is a very common infection that you see in the burns ward, right? So what are the topical burns cream containing? Silver sulfonamides, because Pseudomonas are going to be sensitive to silver sulfonamides. They are susceptible to silver salts. That is, now you will correlate that why in burns do I give silver sulfonamide in the topical ointments? Because they are able to kill the Pseudomonas infection. So sorted. Pseudomonas was the first non-fermenter. The next non-fermenter that I had to do was the Burkholderia. What are Burkholderia? Burkholderia pseudomallei, Burkholderia mallei, and Burkholderia cepacia. I will start off with Burkholderia pseudomallei, and one of the things which most students have a problem. Okay, ma'am, Burkholderia pseudomallei causes maliodosis, or does it cause a problem in humans? Does it cause problem in animals? So pseudomallei and mallei mein confusion hai. So first I will say, read mallei and pseudo ko aise padho. So can I say maliodosis? Yes. So what does Burkholderia pseudomallei cause? It causes maliodosis. And please remember that this is also known as the Vietnam time bomb, because many of the soldiers had suffered from this in the bomb blast. Vietnam time bomb, and VV aayega. This is known as the Whitmore bacillus. This is known as the Whitmore bacillus. So tell me something, Vietnam time bomb. Now just think of a bomb blast. Bomb blast matlab it is gonna spread everywhere. So this is definitely gonna be a bioterrorism agent. Now tell me something, if a bomb blast is gonna happen, what will happen, guys? You'll say, ma'am, bomb blast hua, everything will come down in ashes. What is the culture media? The culture media is ash down selective agar or ash down agar. Please note, ash down agar is nothing but everything coming to ashes after a bomb blast. Ash down agar is nothing but crystal violet with gentamicin. If you want to know, not very essential to know, guys. Crystal violet with gentamicin. So remember, everything comes to ashes. So I definitely need safety from all this that is happening. So microscopically, Burkholderia shows you what? It shows you the safety pin appearance. I have already given you a mnemonic earlier for safety pins when we were doing the previous year Senior Pestis wala chapter, and you know that Burkholderia B was definitely a part of it. So I think it's become so easy now. Firstly, if they ask you maliodosis or does it cause glanders disease, दूसरा वाला, तो you'll say maliodosis. ये वाला maliodosis होगा. It is related to the Vietnam time bomb, Vietnam Whitmore time bomb. से I will remember, oh, it is dangerous, bioterrorism, everything will come down to ashes, so ash down medium, and I need safety against all of this. What is the treatment? The treatment is going to be carbapenem and imipenem. The treatment is going to be carbapenem and imipenem. This is going to be Burkholderia pseudomallei, which means now we are ready for the other one. See, the word has changed. Burkholderia mallei. And you know what happens with Burkholderia mallei? So dekho, if you read it, animalei, that is how you will learn it. So Burkholderia mallei is going to be seen causing animals may disease, and that animals may disease is known as the glanders disease. The animals may disease is known as the glanders disease. Everything is about animals. So Burkholderia pseudomallei was maliodosis in different humans, but Burkholderia mallei you will learn as Burkholderia animalei. Animalei means this is going to occur in animals. It is going to cause glanders disease, and for the diagnosis also you do one animal wala reaction, and that is known as the Strauss reaction. What is the Strauss reaction? The Strauss reaction tells me that if you give an inoculation in the guinea pig, If you give an inoculation in a guinea pig, this is gonna result in testicular swelling. This is gonna result in testicular swelling. So repeating once again, Burkholderia animali, animals में disease कराएगा, cause glanders disease, and diagnosis is also by an animal eye test, that is Strauss reaction, in which the guinea pig shows you testicular swelling. But one thing I don't know if you guys have become too bored of bacteriology by now. Did you even ask yourself कि हो क्या रहा है? Whether you're talking about pseudomalae in humans or malae in animal eye, what is happening in these patients? So what is the clinical features? Because that is the same. The only thing is that one of them is in animals and one of them is in humans. So these patients are gonna have skin ulcers. They are going to have pneumonia and lymphadenopathies. Skin ulcers, pneumonia and lymphadenopathy, even in humans. And the same thing if I ask you in animals, again the clinical features are going to be skin ulcers in animals with presence of pneumonia. So animal eye may be yahi hoga. What are you left with? I'm left with the last one, that is Burkholderia cepaceae. So what you'll do, alternate alphabets pick up karo, okay? Pick up the C, then pick up the P, then pick up the C, and then pick up the A. Pick up alternate alphabets. C tells me this is the most common Burkholderia that you have. P tells me this is also the most potent Burkholderia, and because it is potent Burkholderia, this means it is going to be antibiotic resistant. And finally, the remaining C tells me it is associated with two C disorders, cystic fibrosis and chronic granulomatous disease. So repeating, the first C, it is common. Then the P, it is potent. Then the C, it is associated with C-wala disorders, that is CGD, as well as the cystic fibrosis. And A is going to be antibiotic resistance. So that makes it the very, very famous Burkholderia species, which have come to an end. So your non-fermenters, Pseudomonas, Burkholderia, all those, and even one more, Acinetobacter baumannii, which I told you belongs to the WHO escape agents. That is sorted. Are you ready for some questions of Vibrio and non-fermenters? All of the following are halophilic Vibrio except I know the non-halophilic were only two, Vibrio cholera and Vibrio mimicus. I can see Vibrio cholera over here, so that is the answer. Coming to the next one, statement about cholera which is true. The Eltor biotype is VP positive. I had studied Eltor में तीन चीजें, एक तो carrier state कराएगा, number one. Second, everything is gonna be positive, तो VP test भी must be positive only, and everything is gonna be resistant. So anyway, this is gonna be true. Next, the chick erythrocyte agglutination cannot differentiate between classical and Eltor. Of course it can. Eltor में सब कुछ positive होगा, classical में negative होगा, तो it can differentiate. False statement. Kanagawa phenomena is used to differentiate classical and Eltor. No, this is also false. Kanagawa phenomena is used for Vibrio parahemolyticus. Kanagawa phenomena is parahemolyticus. Tabhi to it was hemolytic was pathogenic strains, non-hemolytic were non-pathogenic strains. All of the following are to bilkul not true. The only true statement that I have over here is Eltor is VP positive. Coming to the next, which of the following is true about Vibrio cholera toxin? Okay, does it produce its effect by stimulating adenylate cyclase? Yes, I had learned that it increases cyclic AMP. So as of now, it is looking true. Does it cause the destruction and invasion of the end? Doesn't cause destruction, it has toxin, cyclic AMP and वो वाला, ये तो ठीक नहीं लग रहा. It causes influx of ions and water into the tissue, ये तो ठीक है. Into the large intestine lumen? No. It is going to be the small intestine lumen. So this is also wrong. Has a molecular weight of 2,88,000. You know it has a molecular weight of 84,000. But do we have to learn molecular weights? No. Because this question was not that you should know every point. This question was you have already found your correct statement. And that is that it stimulates adenylate cyclase, increases cyclic AMP. So the other options were just to confuse you. You had found your answer way ahead. Coming to the next question, the channel activated by the cholera toxin we just now did, it was the adenylate cyclase, right? So this is also sorted for everyone. Which is the transport media for Vibrio? We had studied the two scientists wala naam, Venkatraman Ramakrishnan medium and Carrie Blair medium. So that is also okay. This question is also done for us. Which of the following is used to differentiate the colonies of Vibrio cholera and Vibrio parahemolyticus? We all know it is a TCBS. Vibrio cholera is a sucrose fermenter. Vibrio parahemolyticus is a non-sucrose fermenter. Coming on to the next question. You receive a urine report from the laboratory of a 45-year-old patient who is quadriplegic man with an indwelling urinary catheter. Okay, the urine culture shows more than one lakh, more than 10 to the power 5 colony forming units, that too of a gram negative organism. So see, honestly, when a UTI comes to me na, and significant bhi hai, gram negative bhi hai, E. coli would have come to my mind and I would have thought of E. coli, but E. coli is not oxidase positive. I have to think of something which was oxidase positive and causing catheter. So I know that non-fermenters, the oxidase positive ones are going to be Pseudomonas, and that is going to be